Hi everyone, welcome to my channel Math Made Easy with Terry in 10 minutes. So we'll be talking about how to find the area of a triangle when all three sides are known. Basically, it's called the Heron's formula, all right? So please try as much as possible to review the previous video. It's very important. So because as we keep on going down the series, we try to build on previous knowledge. Is that all right? Also, if you've not subscribed, I don't know what you're waiting for. Please subscribe, click the like button as well as the notification bell. So when I put new videos, you'll be the first person to know. So we're going to find the area of a triangle when we know all the three sides. So we're going to use the Heron's formula, and it's credited to the Heron of Alexandria. Okay. Now, this person was the one that found this formula. Here, he was able to find the area of a triangle in terms of all the sides. So what he said was that if you know the sides A, B, and C, you could find the area of a triangle. And this applies to all type of triangle. Okay, so it applies to all type of triangle, provided that the three sides are known. Okay, so it applies to all types of triangle, provided you know the what? The three sides are known. So you can use this formula to determine the area of a triangle, provided you know the three sides, okay? Now, what he said was very interesting. He found out that the area was equal to the square root of s into bracket s minus a, s minus b, and s minus c. And where s is what we call the semi-perimeter, okay, so S is the semi-perimeter. And the formula for S is equal to A plus B plus C divided by what? 2. Is that okay? So to find the area is the square root of S into bracket S minus A, S minus B, S minus C, where A, B, and C are the sides of the triangle, and where S is the semi-perimeter. Okay, so how do you solve this? There are 4 rules or 4 steps to do this. The first thing is that you have to first identify A, B, and what? C. Okay, you have to identify A, B, and C. Then after that, number 2 is then you have to find a value for S. You have to find the value of S using the formula. Okay, S is equal to A plus B plus C divided by 2. So remember the formula, we had S in the formula, right? Then when you're done finding for S, number 3, you then substitute A, B, C, and the S value you have into the formula. Then the area then will now be equal to the square root of S, S minus A, S minus B, and S minus C. Okay, so where you know where A, B, and C are sides of triangle, or are known sides of the triangle. Okay, then we know the S already here is equal to the semi-perimeter. Okay, all right, so then number 4, when you're done, you then what? Simplify. Okay, so we're going to solve some example now. And what I'm going to do is I'm going to use the same example from the previous video, so that we will use the Heron's formula, because in those examples, we're going to find the size of the three sides of the triangle first. Then we're going to use the Heron formula to find the area and see if we get exactly the same thing we had in the previous video, okay? So we're going to try and solve the same question. So we have this example here. We have given that line PQ intersect the coordinate axis So remember, when we say coordinate axis, we're referring to the X and Y. Is that okay? So the coordinate axis, or you can say the X and Y axis at 0, 4 and 3, 0. We're now told to find the area of triangle OPQ. All right? So as usual, the first step is that we need to find the length of ABC, right? So let's draw this. This is the y-axis and the x-axis. And we're told the first y-intercept is at P, this point here. P is 0 and 4. And the x-intercept is at Q. We're told Q is 3 and 0. So that means this is the line that is being referred to. So the line PQ intersects the y-axis and the what? And the x-axis. All right? Good. So we're finding the area of triangle OPQ. So that means this is the triangle we have here. Triangle OPQ, we're finding the area. And as you know, we know O is, the coordinates for that is 0 and 0. P is 0 and 4. And Q is 3 and 0. So I've solved this question before. Because it's as a right angle triangle, please watch the previous video. I also solved this question as well before when the 3 vertices are known, okay? So now I'm going to solve this question now using the Heron's formula, all right? So in order for us to use the Heron's formula, we need to know the distance for each of them. So this is going to be A, this is going to be B, and this is going to be C. Are you seeing it? So A, we're going to find A, which is the same thing as the line OP, okay? And we know line OP, we know the P is 0 and 4. And we know the O, which is the origin, is 0 and what? 0. So we use the distance formula to find the distance here. So this is the x1, y1. This is x2, y2. So we know the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance will now be equal to square root of the x2 we have is 0 minus 0 all squared plus the y2 is 0 minus 1, y1 is 4 all squared. And when you solve this, this is 4 squared 16, and that will give you 4. So that means our A for that is equal to what? 4. Okay? Now let's go and find B. So for B, we have the B is the same thing as line OQ. Okay? So B is the same thing like line OQ. And that we have the O to be 0 and 0, and we have the Q to be 3 and 0. Okay? So we know this is our x1, y1, our x2, y2. Okay? So the distance is going to be equal to square root of x2 minus x1. Okay? So we have x2 minus x1 all squared plus y2 minus y1 all squared. Okay? And that will give us square root of x2 is 3 minus 0 all squared plus y2 is 0 minus what? 0 all squared. And that will give us the distance. This is 3 plus 0 will give you 3. 3 squared is 9. 9 squared, square root of 9 is 3. So that means the distance for B, so B is equal to what? 3. Now we can find C now. So we know C is equal to what? PQ, okay? C is equal to PQ, and that is our P is 0 and 4, and our Q is 3 and 0, okay? So we're going to use the same formula, x2 minus x1, so it's x1, y1, and this is our x2, y2. So the formula x2 minus x1, so it's going to be 3 minus 0 all squared plus y2 minus y1, 0 minus 4 all squared, and that will give us, this is 9 plus 16, 25. Square root of 25 will give you 5. So the distance for that, C, is equal to what? 5. So that means I can draw this graph again as a triangle. So we have 5 here, we have 3 here, and we have 4. Okay? So that means we can now say, so if this is the graph, 5, 4, and 3, okay? So that means we can now find, we know our A is equal to 4, our B is equal to 3, and our C is equal to what? 5. So we found that. The next thing is that we then have step 2, we have to find the value for the semi-perimeter, right? And the semi-perimeter is A plus B plus C divided by 2. So let's go. Step 2. The semi-perimeter, which is equal to A plus B plus C divided by 2, will give you 4 plus 3 plus 5 divided by 2, 7. 7 plus 5 is 12. 12 divided by 2 will give you 6. So that means our S is equal to what? 6. Okay? Our S is equal to 6. Then step 3, we then have to substitute it into the formula to find the area. Okay? So let's go. To substitute into the formula, we have step 3. The area is equal to the square root of S into bracket S minus A, S minus B, and S minus C, okay? Which will give us the square root of S is what? 6. 6 minus A is 4. 6 minus B is 3. And 6 minus what? 5. Okay? And when you solve this, so you have to simplify. That is step 4. Step 4 is that you have to simplify. So when you put this in your calculator, so you press all this in your calculator, you'll find out that the area is equal to what? 6. And that is the answer for that. So the first thing you do, you first identify A, B, C. You find the S, find the area, and that. And also, you can also identify C by using Pythagoras theorem. So you don't need to find a distance. You don't necessarily have to use the distance formula. So when you have two sides, you can get the second side by using C squared is equal to A squared plus B squared. All right? So any method you want. But the key is that you have to find all the three sides of the triangle in order to apply what? This formula. Is that okay? So let's pick another example, one more example for this video. So example 2, we have the line T has the equation 5x minus 6y minus 30 is equal to 0, okay? And then we're told now to find the coordinates of P and Q, where line T crosses the coordinate axis. So when we say the coordinate axis, we're referring to the X and Y axis. Okay. And number two, we want to use the Heron's formula now. So we want to find the area of triangle OPQ. Okay. So the first thing, step one, is that we then have to find the size ABC. So we're already told that this equation, they intercept the Y and X axis. So we know that at S-intercept, okay, at X-intercept, Y is equal to 0. So please, if you've missed the video on X and Y intercept, just go to the playlist. We talked about X-intercept, Y-intercept, and how to solve it. So I told you at X-intercept, Y will be equal to 0. So for this line, anywhere you see Y, you put 0. So it's going to become 5x minus 6 into bracket 0 minus 30 is equal to 0. Okay? So that will give us 5x minus 30 is equal to 0. Take minus 30 to the other side. So 5x is equal to 30. Then divide both sides by 5. Then x will be equal to what? 6. So that means we can now say for this, at x-intercepts, x is going to be equal to 6, and y is going to be equal to 0. So that's what happens at x-intercept. Okay? So so we can call this is the point P that happened at x-intercept. So we can now find what happened at what? Y-intercept. So at y-intercept, x is going to be equal to what? 0. Okay? So we're going to have, anywhere you see x, you put 0, minus 6y minus 30 is equal to 0. So this is going to give us, this becomes 0, minus 6y minus 30 is equal to 0. You take minus 30 to the other side, so minus 6y will be equal to 30. Divide both sides by minus 6. Therefore, y will be equal to minus what? 5. So that means we can say when x is 0, at y-intercept, y is going to be minus 5. And this is what? Point Q. All right? So now we can now draw the graph to see how it looks like. So we have this. So the first one, we have point P. Point P is at 6 and 0. X is 6, y is 0. So x is 6, so it's going to be somewhere here, positive. So P, x is 6, y is 0. Then point Q, 0 and minus 5. So x is 0, y is minus 5. So this is the positive y. This is positive x. So this will be negative. So let's say this is minus 5. So that's point Q. Okay. It's at minus, x is 0, y is minus 5. Okay. So let's say this is the 2 points here. All right. And this is the origin. And then that is the coordinate at this point. Now, the second question said we should find the area of triangle OPQ. So OPQ. So that means we're talking about this point here. Okay. So what do we do? So let's assume we have, let's call this point here OP. Let's call this the side A of the triangle. Then B, PQ, let's call this side B, and OP, let's call this side C. Okay, so now let's find the use distance formula, because we already know that the coordinate of the origin is 0 and 0. So using distance formula, so we know A, which is equal to OQ, okay, will be equal to the O, and what? The O, we know the O is 0 and 0. And we know the q is 0 and minus 5. Okay? So this is x1, y1. This is x2, y2. So apply the distance formula. The distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And that will give us square root of x2 will give us 0 minus x1, 0 squared, plus y2 will give us minus 5 minus 0 all squared. And when you solve this in your calculator, this is 5 squared, that's 25. Square root of 25 will give you 5. So the distance is 5. So A will be equal to what? 5. A is equal to 5. Now let's go for B now. So let's do B. So we know B, which is equal to PQ. Okay? And we know our P to be 6 and 0. And we know our Q to be 0 and what? Minus 5. Okay? So 6 and 0 and minus 5. So what can we say? This is the x1, y1. This is the x2, y2. Okay? Then we'll now put it in the distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. And then you put this in the formula. So to be square root of x2 is 0 minus x1 is 6 all squared plus y2 is minus 5. Then y1 is 0 all squared. And when you put this in your calculator, that should give you square root of 61. All right? So that means our B is equal to what? Square root of what? 61. Then we can find the C, which is the last one. So the C, which is equal to OP, okay? And that is the O, which we know to be the origin, is 0 and 0. And we have the P, which is we know to be point P, to be 6 and 0. So this will be our x1, y1, our x2, y2. So the distance now will be equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. So that will be equal to the square root of x2, 6 minus 0 all squared plus y2, 0 minus 0 what? Squared. And this will give you 36. Square root of 36 will give you 6. So that means the distance of OP is equal to 6. So that means I can draw this graph again, but this time I can draw it this way. So the triangle here is 6. Here is square root of 61. And here is what? 5. Okay? So now we're going to apply the Heron's formula now to get the value for this triangle. Okay? So now because we know the 3 sides, then we can apply the 4 rules in order to solve them. So let's look at the rules. So the first thing we're told to do is to identify A, B, C. So we've done that already. So we know our A to be equal to 6, our B is equal to 5, and our C is equal to square root of what? 61. So we've done that already, right? So what's the next step? The next step is that we then have to find the value of S using the formula. S is equal to A plus B plus C divided by 2. So let's do that. So step 2, S is equal to A plus B plus C divided by 2. And that will give us the A is 6, 5, and root 61. So we have 6 plus 5 plus root 61 divided by 2. And that will give us 11 plus root 61 divided by what? 2. We've gotten the S. Then step 3. So step 3 now said we should find the what? The area. We should substitute the A, B, C, and S into the formula, into the area, which is the square root of S, S minus A, S minus B, and S minus C. All right? So let's do that. So the area is equal to the square root of S into bracket S minus A, S minus B, and S minus C. And that'll give us the square root of S is 11 plus root 61 over 2 into bracket S minus A, 11 plus root 61 over 2 minus 6, okay? Then 11 plus root 61 over 2 minus B is 5, and you have 11 plus root 61 over 2 minus C is what? Root 61. And when you press all this in your calculator, your area will give you what? 15. Okay? And you get the same thing we got last time. All right, so that'll be the end for this video, where we talked about how do you find the area of a triangle using Heron's formula. All right? So you'll have to use Heron's formula. You need to know the 3 sides of the triangle. So this can only happen when you know the 3 sides of the triangle. Then you apply the formula, and you can also apply the semi-perimeter for that. And the area is equal to square root of S into bracket S minus A, S minus B, S minus C. All right? And that is that for that. So please don't forget to subscribe and click the notification bell, so when I post new videos, you'll be the first person to know. So I will see you in the next video, and I'll see you soon.